Alright, let's get back to page number 6 of worksheet 8.3. Before that, let's recall we have learned the ASTC diagram, complementary angles, negative angles, supplementary angles, and in the 4 quadrant, how does the trigo ratio of general angles compare with the trigo ratio of the basic angle? Okay, for A, S, D, and C, first, second, third, and fourth quadrant. Okay, you need to have this page ready. So let's say you cannot remember, maybe you have to flip over, okay, to this page number 5. Okay, let's look at page number 6. This question over here. Given that theta is between 90 to 360 degree and tangent theta equals to 3/4, calculate the values of sine theta and cosine theta without using a calculator. Without using the calculator, it just means that you don't go and find theta. Okay, you don't go and find theta equal tangent inverse 3/4. You don't do that, because by doing so you are using your calculator. So how to do this question? Okay, we have to draw a triangle. Firstly, let's decide based on this clue number 1, clue number 2, where will theta lie? First, second, third, or fourth quadrant? Based on this information, 90 to 360, it just means that 90 to 360, that means it is either in the second quadrant, the third quadrant, or the fourth quadrant. Does it make sense? Okay. You draw the 4 quadrant. First, second, third, fourth. First, second, third, fourth. So 90 degrees here, all the way to 360, so it's second, third, or fourth. But now, based on the second information, tangent theta equals to 3/4. Take note, when they say tangent theta equals to 3/4, it means tangent theta is positive. Okay? Recall earlier on, when will tangent theta be positive? Tangent theta will be positive in the first quadrant. Tangent theta will be positive in the third quadrant. So only first or third, A or T. Alright? So let's recap one more time. Recap what I've taught you earlier on, ASTC. In the first quadrant, all of them, sine, cosine, tangent, are positive. In the third quadrant, only tangent is positive. So since tangent is positive, I conclude that it is either in the first or the third quadrant. So now, given that theta is between 90 and 360 and tangent theta is positive 3/4, both information directs me to conclude that theta must be in the third quadrant. Okay, because third quadrant appeared in this and this. So theta must lie in the third quadrant. So I conclude theta is in the third quadrant. Okay, so in this question, Mr. Liu will teach you how to draw a triangle in the third quadrant. So recall, how does the quadrant look like? Let's draw a triangle in the third quadrant. First quadrant, second quadrant, third quadrant. Third quadrant is here, and recall how you draw the angle in the third quadrant. It will go right here. Then recall that you draw a line OP. Okay, remember OP. So with that, this is theta. This huge angle is theta. And from the point P, you draw a perpendicular line down all the way until it hits the x-axis. There you go, you get a right angle triangle. So based on this right angle triangle, I can solve my question. I can find out what is sine theta, what is cosine theta, because I've learned Tuakaso. So let me write down Tuakaso here. Tuakaso. Okay. So tangent theta is 3 over 4, right? So let me write down. If tangent theta is 3 over 4, theta is here. So this will be my reference angle, or my basic angle, alpha. Right? This will be opposite. Tangent is opposite over adjacent. Opposite is 3. Adjacent must be 4. The last one is the hypotenuse. If this is 3, this is 4, Pythagoras theorem tells me that this must be 5. Okay? So 3, 4 and 5. 3 square plus 4 square give me 5 square. Okay, so now with this information I can solve these two questions. And I will also need to know ASTC. So let me draw ASTC somewhere. Okay, let's draw here. Just for practice, I will draw this out to remind myself that first quadrant all will be positive, second quadrant sine will be positive, third quadrant tangent positive, fourth quadrant cosine positive. So let's see. Sine theta, let's decide what's the number first. Sine theta will be opposite over hypotenuse, 3 over 5. So the ratio will be 3 over 5. Okay, but if you go and check the answer, it's confirmed wrong. Okay, the answer is negative 3 over 5. Why is it so? Okay, because I drew this ASTC. I must recall that in the third quadrant, only tangent is positive. In the third quadrant, only tangent is positive. So sine, you have to be negative. Negative. Okay, that's how you can make use of ASTC to solve a problem, to decide whether is it positive or negative. Okay, so now for cosine, let's try again. For cosine in the third quadrant, should it be positive or negative? Yeah, only tangent is positive, so it should be negative. Negative what? Let's look at this triangle. Cosine means adjacent over hypotenuse. Is this adjacent? No, this is opposite. Adjacent is 4, hypotenuse is 5. So it's negative 4 over 5. Check both answer. Correct. Okay. Okay, let's proceed on. If you need more time, please pause the video. If not, let's proceed on. Example 2. Given that sine 50 degree equal to P, express the following in terms of P. Sine 230, cosine 50, tangent negative 130, and sine 40. This question over here, question 1, should be quite straightforward. But I need you to try to relate 230 with 50. 230 with 50. What's the relationship? 230 is actually 180 plus 50, right? So let me draw a simple diagram for you to relate. 230 is somewhat here. Okay? So this is 230, so the alpha will actually be 50 degree. Can you see that? If theta is 230, alpha will be 50. The basic angle will be 50. Okay, sorry, I draw a small diagram because I need a space over here. So I make use of the formula that I've learned earlier on. Sine 230. 230 is in third quadrant. I'll look at third quadrant. Okay, same thing. Theta alpha. Sine 230 equals to negative sine alpha. Right? Let me write down. Sine theta equals to negative sine alpha in the third quadrant. So I can conclude that sine 230 degree equals to negative sine 50 degree. Negative sine 50 is P. Sorry, sine 50 is P, so I replace sine 50 with P. The answer is negative P. Okay, first question done. Let's try question B. Part B, cosine 50 is first quadrant, but what formula should I use? How should I relate this question? Cosine 50 degree. They only give me sine 50. How to find cosine 50? Okay, let's think about drawing the diagram. Drawing a triangle. Draw a simple triangle here. Okay. Draw a simple triangle, right angle triangle. If this is 50 degree, and they say that sine 50 degree equals to P, right? P. So if sine 50 equals to P, P can be also seen as P over 1, right? So sine 50 is opposite over hypotenuse. Okay? Tuakaso, remember? Okay, if you cannot remember, let's write beside here. Tuakaso. So sine 50 is opposite over hypotenuse. Alright? So Pythagoras theorem tells me that this side will be square root 1 square minus P square. 1 square is 1. So I'll get this. Okay, this triangle will be very useful. It will help me to solve part B, maybe part C, and maybe part D. Let's see. So part B, cosine 50 degree. You can recall CA, adjacent over hypotenuse. 50 degrees is here, opposite is P, this is adjacent. So adjacent is 1 minus P square over 1. Okay, good. So answer is square root 1 minus P square. Okay, I have to pause the video here because the video will be too big for uploading. I will continue in the next video.